Welcome to Fire Rapid Diagnostics. I'm Dr. Shannon Hilton, the faculty leader for this research. In the Rapid Diagnostics lab, we develop, test, and build fast, easy-to-use sensors for real-world problems. Many health and environmental issues require sensors for disease detection or environmental monitoring. The locations where the tests need to be done don't always have labs for a number of reasons, including low resource settings, community health clinics rather than doctor's offices or hospitals, or testing in the field or out in the real world. You've probably seen examples of these point-of-care sensors before, and maybe even used one. Home COVID tests, pregnancy tests, and glucose monitors are all common examples of point-of-care sensors. The Rapid Diagnostics lab research sits at the intersection of chemistry and bioengineering. Over the course of 2 semesters, students in this stream spend time in both a wet lab and a fabrication lab, and learn skills ranging from pipetting, making solutions and taking measurements, to 3D modeling, CAD designing, 3D printing and cutter plotting, to data analysis and presentation. Some problems we're tackling right now in the Rapid Diagnostics lab include monitoring biomarkers for maple syrup urine disease, a genetic disease, and developing a dipstick test for creatinine in urine, a biomarker for kidney dysfunction. We work on optimizing the chemistry to enable the detection. In these cases, this involves determining the best way to make a color change. Then, we work on translating the test to a format that can be used with minimal instructions, so that an untrained user could successfully run the test. This could include using paper fluidics or microfluidics, putting the test onto paper, like a home COVID test or pregnancy test, or using small millimeter or smaller channels to contain the test. Microfluidics is the manipulation of small volumes of liquid, microliter volumes, in microchannels, which are spaces with at least one dimension measured in micrometers. That's 1/1000th of a millimeter. These small channels give us access to unique fluid properties, including the low Reynolds number that enables these 2 colors in this video to flow side by side without much mixing. Paper fluidics is a subset of microfluidics, where the sensing is done on paper rather than in a microchannel. You've likely seen one of the most common examples of paper fluidics. An at-home COVID test is a lateral flow immunoassay, which is a type of paper fluidic sensor. And we often use colorimetric chemistry in our assays, since it enables the readout of the sensor to be done easily without extra equipment. Most people can see either a color change or the development of a visible line. Our sensors are designed to be point of care, meaning they're usable outside of a central laboratory facility, without the need for expensive or delicate equipment. Many places worldwide have limited infrastructure for the gold standard types of analysis. Rapid, on-site analysis is critical in many situations. For example, to stop the spread of disease, for triage at the site of an incident or in an ambulance, or for responses to environmental disasters. The World Health Organization has established a set of criteria that we use as our guiding principles in developing our sensors. The devices should be affordable for the location and the people that will need it. They should be sensitive and specific, meaning that they'll work well and have minimal false positives or negatives. They should be user-friendly, or it doesn't need lots of training, rapid, fast, robust, can be used in varying environments without special storage requirements, equipment-free, meaning that it's a self-contained test, and deliverable to end users. It can get where it needs to go. It can be shipped, sent, it's okay if dropped, etc. The Rapid Diagnostics Lab develops, designs, builds, and tests point-of-care sensors for use outside of the laboratory as students develop chemistry, design, and engineering skills that are directly applicable for health and environmental monitoring needs. I encourage you to check out our website and reach out to me if you have any questions.